Hello my dear student, you are watching lecture on CHO 351 and we are working on combined problem on spectral data. Spectral data like UV IR H1 C13, C13 of resonance decoupled, proton decoupled and mass spectra. Okay, and by using this information you have to deduce the structure. So very first question is what what is this X? Any halogen atom, but which halogen atom? I am expecting you to give answer. So just look at all the information and predict what is X. If you look at mass spectral data, you will see 194, 196 in bracket m plus 2 plus peak in 1:1 ratio. The moment you see 1:1 ratio difference is 2 m plus 2 plus peak, then it is which atom? Bromine atom. That is also one bromine atom because one bromine atom will show in mass spectra 1:1 intensity ratio. Two bromine atom will show 1:2:1 like this. For chlorine, 2 chlorine, there are so many. But for now, just consider 1:1 it belong to one bromine atom. So your molecular formula is going to be C6H11O2Br. Now just calculate site of unsaturation or degree of unsaturation. What you will get? You will get site of unsaturation is 1 by using this formula. Then at UV, if you look at UV data, no significant absorption about 210 nanometer. No significant absorption at about 210 nanometer means there is no conjugation, no any double bond. Okay, it is aliphatic chain. IR data 2910 per centimeter, 1720 per centimeter, 1250, 1190. 2910 indicating CH trace of alkyl also, and if it is weak then it is aldehydic CH trace also. There is no any, they don't mention anything weak, it is significant bands they mention. So 2190 it is alkyl stretch, CH stretch of alkyl aliphatic chain. Then 7 1720 per centimeter, 1720 per centimeter, it belong to carbonyl. This carbonyl could be ester because we have two O2. It could be ketone, aldehyde, anyway it is going to rule out. There is no any significant stage of CH aldehydic CH stage. But for now just consider there is presence of ester, ketone, aldehyde and acid also. By using H1 data we will rule out the possibilities. Okay, so 1720 indicating presence of this four functional group. 1250, 1190 this is indicating alkoxy, carbon oxygen stretching. H1 data, at H1 data if you look, then there is 2 methyl, both are showing triplet. One is at 1 delta, other is 1.3 delta. 2 CH2 group, one is showing multiplet at signal is 2.05, other is showing 4.20 quartet. This must be near to any electronegative atom. And then one hydrogen signal at 4.24 showing triplet. This is also nearby some electronegative atom or group. Then C13, in C13 they give two data of resonance decoupled data. This is of resonance decoupled data where you can see multiplicity directly attached carbon and hydrogen. And this is proton decoupled spectra 10, 14, 28, 48, 62, 170. That means there are 6 different carbon. And if you look at mass spectra, then 194, 196 all indicating presence of bromine. So the signal what indicate one methyl having triplet means neighbor should be CH2. This is also one methyl Showing triplet means neighbor is CH2. This CH2 showing multiplet, that means there is CH3 and more than that it is showing multiplet. Maybe here also CH2 because CH3 not possible, otherwise this molecule will finish with 3 carbon only. So CH2 or CH, consider CH2 here because we have two CH2. One CH, one EH also it is there, so it could be CH3 CH2 CH, like this. Then this is showing carbon with one hydrogen, showing triplet, that is CH2 is nearby. So this is in agreement with this, so we should rule out this. And of course we have presence of one ester, one halogen. So let's organize these pieces. Now there should be one CH2 which will be very deshielded downfield. So this CH2, look at this CH2, it is at 4.20, it must be here, and it is showing quartet, that means it have CH3 here. So remaining fragment is this only, CH, CH2, CH3, and halogen should be here. So this is going to be your molecule. You can cross check this molecule with fragmentation pattern. Just knock out one electron, it will give M by Z 194 and M by Z 196 because two isotope of bromine. Then just do alpha cleavage. This electron, the bond. This will give M by Z. It will also give two M by Z values. One 49, 151. So we had spectral data 194, 196, 166, 168, then 149, 151, 121, 123, 115, and 29. So we have this, we have this, we have this, we have this. Let's check other fragment. This will give M by Z 115. So we have 115 also. Next you can do alpha cleavage here, inductive cleavage. This will also show two M by Z values, 121, 123, 123. Then there is a question of 166, 168. After McLafferty, you will get this fragment. This will give M by Z 168, 166. Done. Remaining 29. Alpha cleavage possible on both sides, so just do alpha cleavage on this side also. But here it will immediately gives out CO2, and this fragment will show M by Z 29. So it is confirmed this molecule is this only. Okay. There there was possibility of OH, means carboxylic acid also, and aldehyde also, but in H1 spectra we didn't see anywhere 11 delta or 9 delta, so aldehyde, carboxylic acid were ruled out. And if you change the position of bromine, then all H1 data will disturb. So it is confirmed that bromine is here only, and it is in agreement with all data also. In M by Z values data also it is in agreement. So this is the final structure. Now you can check this structure by C13 values also. 13, most of the time it is. Now here 2 methyl we have data 14, sorry, 10, 14, 28, 48, 62 and 170, 62, 170. So it is very obvious 62 is here, 170 here, and 48 here, 28 here, 14 here, 10 here. Okay. Why this is 10, 14? Both are methyl, but here 10, here 14, because if we predict value by using alpha beta substituent, then carbonyl is very near here. One carbon is coming in here. So 14, 10 is okay. 62 okay. 48 okay, because carbonyl and bromine also present. Actually, bromine iodine not that much affecting in C13 spectra, but here carbonyl also nearby. So 48 here only. 10, 14, 62, remaining 28 here only. So in and of resonance decoupled, they give two quartet. So this CS3 will give two quartet in off resonance C13, and here two triplet, and here one doublet, one singlet. So this is your final structure. I didn't mention here how to calculate sites of unsaturation. To calculate site of unsaturation, just neglect oxygen and replace halogen with 1H, so it will become C6H12, and fully saturated molecule would be C6H12 plus 2. So just subtract this 1412, 2 divided by 2, 1 site of unsaturation 1, or you can use formula 2C plus N plus 2 minus X minus H divided by 2. Anyway, this is your final structure, and thanks for watching. We will meet in next lecture with another example.